Hello everybody, Zero Fossil Fuel. Today is Tuesday, February 7th, 2012, and we're here at the shadow of the full moon at the Farmington Hampton Inn Hotel. And with us today is Matt Ryder, aka Hillbilly on the forums and in the chat rooms. And today we're going to talk about the Vulcan Gasifier company that he has started and the 2 units that he has developed and has already begun to produce and take orders for. Matt, I want to thank you very much for joining me today. It's a real pleasure to interview you. I just want to start. I mean, a lot of my audience may not even know what a wood gasifier is. So why don't you tell us, what is a wood gasifier?
In the simplest terms, basically what it does is it takes a biomass and rapidly decomposes it through a thermal process. And to get a little more scientific, basically what you do is you introduce a little bit of air into the fire pot. Okay, and then you consume some of your biomass with the air, and you generate the heat from it. Now, as your oxygen is depleted through that combustion, what you're left over with is heat. And then now what you start doing is you start performing pyrolysis. And that can only happen without the presence of oxygen. So there can't be any oxygen. It has to be consumed through the combustion on the outer portions of your fire pot. Okay, now what this is doing is this is taking your molecule chains and it's ripping them apart in all their individual elements. And then as this is happening, it goes down through the down tube, and what you have is you start beginning to create a char, and that also acts as a catalyst to help in this process. Now once it gets through the down tube, hopefully what you have is a completed process to where you don't have any tars left over, but that's very difficult to do. So the hotter you can get it, the better pyrolysis that you can get, and the cleaner your gas.
Okay, so you've answered my 4th question here. How does it gasify your biomass without actually burning it? Because in the beginning of your videos, I see you ignite it through a port, and you force feed air into the bottom of this thing, and you got a really bright flame going in there, and you close it off, and then you're doing something, and I don't quite I can't quite wrap my head around why the whole thing doesn't just go up in smoke.
Okay, now, well, the ignition port, that's just so that I have access, I can get flame and have access into the burn pot or the burn chamber. But once I have once I have it ignited, then I can close that off, and then what I do is I open the port to the side that you see there.
Right.
And you introduce air into this. This is an air jacket, and it's actually it's hollow around the burn pot inside this jacket. And then I have jets drilled to a specific size for this unit, for the size of the hearth. And and then air is injected into the burn pot.
At a very controlled rate, then.
Yes, exactly.
Okay.
It's the penetration, how far the air penetrates into the burn pot, and the volume.
Okay.
The geometry on a gasifier has to be exactly right. There's an ecosystem that happens inside this, and if you don't have your geometry right, or if something's out of whack, you're going to mess that ecosystem up, and you're not going to produce a very clean gas.
Okay. So what are the practical uses for a wood gasifier?
The best practical use is for running a generator. I would not put this thing on a car.
I've seen people do it, and it looks really dumb, but they can make it work. But
if we're running a car, I don't know why we don't just switch to ethanol and be done with it.
Right.
Yeah, for home generation, I think a gasifier is a great way to get off a grid. Also, it would be great for emergency power, and that's what the M1 is for. Is for uses like that. Also, it could be used to run any 5-horse engine.
To pump water or to do whatever.
Pump water, a wood splitter, a wood chipper to make its own fuel.
Right.
it'd be great for like an RV camper for auxiliary power. That'd be a cheap method of doing that.
Okay. What kind of stuff can you feed it? Now, there are a number of people who have been making these. You're not the first one to make a wood gasifier. It's been done for 100 years.
Correct.
Okay. What you've done is you've attempted to modify the technique and to add refinements to it that make it more compact, cleaner, and easier to run. Yep. Now, some of the units that I've seen out there say, well, you can feed it wood chips and you can feed it briquettes, but you can't feed it wood pellets, and you can do this, that, and the other thing, but you can't do this one other thing. And what is it that limits what you can feed this thing, and what can you feed yours as opposed to your competition?
Well, size of your hopper, the reduction, the reduction bell inside of it. You see how mine's it's a straight cylinder,
right?
So the reduction zone is the word I was looking for. My reduction zone is right here, and it's very small. My outside diameter compared to my hearth diameter are only about 1.5 inches apart. So when the more deviation you have there, that kind of limits your flow. So if you have like a lot of odd sized, like say wood chips, it's not gonna. When it gets to that point, you could start binding up, and then it'll cause a bridging effect.
Okay.
And then it kind of deadlocks it, and.
Okay, that sort of clears it up for me a little bit.
But also, your hopper size, like with the M1, it is a small gasifier. If you put wood chips in it, your hopper's not gonna last very long for runtime. So I suggest running just stick with pellets for the M1 in this state. However, I do try to make this unit versatile by offering the expandable hopper, which triples its runtime.
So really? So there's an additional hopper you can throw on top of that would increase the capacity.
Correct. Yes, you can remove the lid, and then the hopper actually bolts in place of where the lid actually is fastened down.
Wow.
So that'll triple your capacity, and then like if you want to run a 10-15 horse engine, then you can run
it for a long
chips
time.
On it.
Sure. Yeah. Okay. Now, when you have this connected to an engine, and you're taking the gas output of this thing, how do you regulate the gas output of this thing into your internal combustion engine? I know in some of your videos, I see you light the thing, you're turning valves, and you're saying, okay, now we're gonna let it cook for a little while, and I see a blue flame coming out the stack, and you shut that valve off, and the blue flame stops, and the only thing I can think of when I see you do that is, God, there's got to be pressure buildup inside this thing now all of a sudden. How is it that you're regulating the gas flow coming out of that thing so that the motor can run at a steady speed?
Actually, I'm always pulling negative pressure on it. Always.
You're always pulling negative pressure, meaning the vacuum from the engine is pulling on the gasifier. Okay.
Yeah, there's never positive pressure in the unit. Basically, I'm pulling on it through the venturi to light it, and then once it's up to temp and producing a decent gas, then I just shut that part of it off and close that off, and then open the system up to the engine, and the engine pulls it in. And then to adjust your air-fuel mixture, it's just a simple ball valve setup. You got a ball valve for the gasifier and a ball valve for your intake, and you just set them up to get your mix to where the engine runs optimal, and you're good to go.
And what do you think sets your design apart from your competition?
The quality and the price. What I'm trying to do is build a high quality system for an affordable price that anybody can afford. I do have competitors out there that build awesome equipment, and I will not bash any of my competitors. For instance, I'm not going to mention the name, but if I were to compare them to an automobile, they would be the Ferrari of gasifiers.
Right.
What I want to be compared to would be like Chevrolet or Ford,
Right.
You still want to build a high quality unit, but
one that people can afford.
This is something that just the normal average person can afford. And this This right here is our most affordable unit. It's very versatile. Like I said, you can add the expansion hopper on it, which makes it a bigger unit, more capable of running larger systems.
Are there any stainless steel components in that, or is this all?
The M1, no. The M1 will be strictly just mild steel.
Okay.
When we get into the economy series, that is going to be the beginnings of the bigger picture of making an off-grid system, and I'm going to build that in a modular fashion so that it can be upgraded.
Right.
So right now the hearth is going to be built on a mild steel, but then later on when we start developing this unit further, you can upgrade your unit to a stainless steel hearth.
So a unit built from mild steel, how long could you reasonably expect, and what kind of service life would you expect out of it?
About 5 to 10 years.
Okay.
I've been talking with a few other people and getting some input there because I've only been doing this a short time and I really don't have data from my own experimentation. But I have been in touch with some people that are in and they were telling me about 5 to 10 years, no problem.
Okay.
With the gauge steel I'm using.
Now, from our discussions earlier, you said that you're not going to open source your plans, but you are going to offer a kit.
I do offer a kit. It's on the website for $300. There's about $100 in material cost plus about a day and a half's worth of labor put into it.
Okay.
And then the experimenter that buys it, they can take the plan and make their own adjustments and do their own. That's what it is, an experimenter's kit. It's for you to build and give you the basic instructions, and if you want to change it, change it.
Cool. Now, what will the pricing be on your fully assembled units?
The fully assembled E1 is going to probably retail for around $1,200.
Okay.
The M1, as you see it here, retails for about $800. Comes with everything you see there: the gasifier, the cyclone, and the heat exchanger condenser.
Okay.
There are a few changes that I am going to make to the filter system, and it's really nothing that's going to change the operation of the design. It's just I want to make it serviceable so that both units can be cleaned periodically.
That's important.
Yes.
Yeah, that's really important. And if my audience wants to contact you, how do they get a hold of you?
VulcanGasifier.com.
Okay. Do you have a telephone number that you want to give them?
Yeah, if I can remember. It's 231-720-5126.
Okay. And that telephone number is also at VulcanGasifier.com. That's VulcanGasifier.com. And that's all for now. Zero Fossil Fuel. Matt, I want to thank you for this interview. I hope you do real well with your business. It looks like you got a great product. I mean, it's not, like I said in my last video, it's not right up on the fringe sciences that we like tinkering with, magnetic motors and gravity wheels and all that. But this is real world technology that works right now. And if the pumps stopped tomorrow, we could use this tomorrow.
Absolutely.
And just literally just be independent and off the grid. Yep. Hopefully, maybe not with the M1, but certainly with the E1. That's all for now. Zero Fossil Fuel. Everyone, take care. Peace. Fossil Fuel. Today is Tuesday, February 7, 2012, and in the shadow of a full moon, I'm here in the Farmington. What is this? The hotel.
Oh, it's the Hampton Inn.
Hampton Inn, yeah. Good interview.
Yeah, and I'm really nervous when it comes to cameras, if you couldn't tell from my videos.